This semester, our project is determining individual opinions via analysis of followed Twitter accounts. The problem we are trying to solve is determining if we can perform sentiment analysis on Twitter users by analyzing who they follow. To do this, we would collect Twitter users into one group and then gather all their followers into another group to create a bipartite graph. We would then analyze this graph to try to determine information about users based on the collection of followers that they have. For example, trying to determine political affiliation based on who they follow and what political affiliation their followers have. You might be wondering why this is useful. Analyzing followers has the potential to provide different information than what you can gather by analyzing tweets themselves. For instance, there are many users that do not tweet very often. However, these users can have a whole bunch of followers, and therefore there's information that we can gather about these users based on analyzing their followers. Another aspect is that there are topics that many people don't tweet about. There's potential to be able to analyze who they follow and gather some information about these topics that you wouldn't be able to gather just by analyzing the text of tweets. This project is novel in that we're analyzing Twitter followers. There are many projects out there that analyze the text of tweets, that analyze the hashtags of tweets, but there is nothing out there that is trying to gather information based on the group of followers that a user has. Next, David is going to talk about our approach to solving this problem.
Hello, my name is David Wales, and I am here to discuss the approach to our topic, the applications to real life, and where we could go next. To start, our implementation. We were given two datasets with two files each that each contained a separate opinion on a topic. We then took these two files and we combined them into a single file for each dataset, where we added a column class that represented the opinion. 0 represented one opinion, while 1 represented the other. From the data we read in, we split it so that 80% of the data comprised the trained dataset, and then the other 20% represented the test set. We then took 10% of the trained set to use as validation data at each epoch in the neural network. Our neural networks train for a maximum of 1,000 epochs, but will stop early if it detects that the validation loss has not improved in the last 5 consecutive epochs. To analyze the data, we had a variety of different classifiers and feature generators. For classifiers, we had linear support vector machines, random forest, a nearest neighbor, single hidden layer dense neural network, single hidden layer convolutional neural network. For feature generators, we implemented a bag of words, Keras embedding layer, and Gensim word-to-vec method, where the embedding layer and word-to-vec method needed some aggregate function to bring its dimensionality back to two-dimensional. Now for a short demo. So the first one I'm going to run is I'm going to run a single hidden layer dense neural network using a word-to-vec feature generator with a medium aggregate. So we're going to use the political dataset, and we're going to run it. So the first thing you'll see is that it reads in the data. Next thing you'll see is that it's performing the word-to-vec method on that data. Now, once this is done, that'll output a 3D structure, and then on that 3D structure, it'll perform an aggregate on each third dimension to bring it back down to two-dimensional. So once this finishes, it will take this data and it'll spit it into the neural network training method. And you'll see here the validation loss and the validation accuracy. And at each step you can see it's getting better, but once it stops getting better, it'll stop and it'll try using the model it has trained, and it'll try classifying the data in the test dataset. Okay, it's done. Right, for 361 epochs, and the final accuracy was 86.458%. Not too bad. So the next demo I want to show is I want to show an SVM analyzer using a bag of words feature generator. So you'll see here I just changed feature generator to bag of words and network analyzer to SVM analyzer. And we're going to run this one on the Socrator dataset. Yeah, specify there. So you'll see that this runs very similarly. Had to save it. You'll see that this runs very similarly to the neural network, where at first it read in the data, then it trained the model, and then it classified the test dataset. This one achieved 91.66% accuracy. Not too bad. Next, we're going to cover the results. So for our results, we ended up running every permutation of classifier and feature generator and logging it in a spreadsheet, as you can see here. For this purpose, we only took the first result of running the model, so this may not be representative of the accuracy for each run, as there is variation. As you can see in the picture on the right, which is sorted by political accuracy, we achieved 89.58% accuracy in the political dataset with a single hidden dense neural network using the bag of words feature generator. The soccer dataset, on the other hand, performed best using the single hidden dense neural network, using a word2vec feature generator that used a median as the aggregate function. This achieved 93.75% accuracy. Now, for the real-world applications. So, for the political dataset, the ability to classify an individual as one political view or the other, or anything in between, may be beneficial for political candidates in the fact that, let's say, you're a Democratic candidate running for the primary of your party, and you have a list of Twitter users, and you need to figure out who do you want to try to sway to vote to you. Well, your best bet is to filter that list down to include only Democrats. It's pretty likely that Republicans aren't going to be voting in the Democratic primary, so you'd be wasting your time trying to target them. On the other hand, the soccer dataset might benefit from this in advertising. Say, Manchester United likely doesn't want to waste money advertising apparel or season tickets to fans of one of their rivals. These people are much less likely to be affected by the advertisement. Instead, they can target users that are Manchester United fans already, who are much more likely to buy their product. Finally, what's next? Well, we certainly did a lot, but there's definitely a lot of room to growth. For instance, perhaps a different aggregate function besides mean or median would perform better, or perhaps an entirely new feature generator. With so many different classifiers and feature generators, it is likely that the parameters were not tuned very optimally for each permutation. Given more time, it may have been extremely beneficial to try and tune the parameters for each permutation to achieve better accuracy. One last point in which we may have run into an issue, but it's uncertain, we didn't have much information, is that there wasn't much information on how our data was collected. For instance, if the political data set was collected using politicians, well, it's pretty obvious why we performed pretty well. Likewise, if the soccer data set was collected using players of different soccer teams, well, it's pretty clear that Manchester fans are probably, or Manchester players are probably fans of Manchester. So, also not very realistic in the real world. With more information on the dataset, we might have been able to exploit certain characteristics of it to achieve better accuracy. In conclusion, I think that we were able to test a large amount of experiments which achieved good accuracy. Without doubt, there is much more that could be done in the realm of classifying these datasets. Having such a large dataset out there, however, poses a unique opportunity for researchers to delve into the data that Twitter holds and to use it to start classifying people in certain ways that could benefit different professions, such as politics or soccer or any kind of other sports or anything. On that note, thank you for listening, and we hope that you found this interesting.